Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this revision video in which I go through everything you need to know for your upcoming test. So the test covers algebra and also index laws. Let's start with the algebra. So algebra is basically just the study of mathematical operations, and in order to study how these affect any number, we need to have things that stand for numbers, and we call those things pronumerals. So pronumerals are just letters that stand for numbers. We usually use the letter X, but we can use any letter we want. So it just stands for an unknown number. So there are a couple of other definitions that we need to understand before we go any further. So we need to know these definitions on the screen. So firstly, a term. A term is just a sequence of pronumerals and numbers. 2 is a term. 2x is a term. Minus 17x squared is a term. xyz is a term. So these are sort of the building blocks that we're going to use in our algebra. So just numbers and letters stuck together. An expression has two or more terms separated by plus and minus signs. So something like 2x plus y is an expression. Something like 4x minus 13 is an expression. Now, coefficient just means number in front of, and we're talking about the number in front of a pronumeral. So in this expression here that I've underlined, the coefficient or number in front of x is 4. Here, the coefficient of x is 2. The coefficient of y is 1. If it's not written, we assume it's 1 because y and 1y are the same. So it's important we understand these because I'm going to refer back to these throughout the algebra section of this video. So now we'll get into it and we'll look at substitution. So substitution is when you have an expression and the expression involves a pronumeral, and you exchange that pronumeral for a number. So for example, we might have the expression 2x plus 7. So that's an easy one. So let's say I want to substitute in x equals 3. So all I do is I take my expression, I get rid of the x, and I change it to 3. Now note, 2x doesn't mean 2 is the first digit and x is the second digit. 2x is 2 times x. So I need to go 2 times x, which is 3, plus 7. And then if I put that on my calculator or do it in my head, I get 13. So that's what it means when it says evaluate the expression. Give a value to. Sometimes you'll need to substitute in more than one pronumeral at a time. So let's say I have something like 2ab minus b squared. And I'm told that a equals minus 3. And b equals minus 4. So I'll do the same as what I just did. So I'm going to get rid of this a, and I'm going to change it to a minus 3. So now I'm going to change the b's. Everywhere I see a b, I'm going to replace it with minus 4. Now, when I'm replacing this b by minus 4, whenever you're writing in a negative into an expression, it's usually helpful to put it in brackets. So I might put brackets around this and this, just to make it a little easier. So I want to evaluate that, give it a value. So 2 times negative 3 times negative 4 is positive 24. Negative 4 squared is positive 16. So I've got 24 minus 16, which is 8. So I've evaluated the expression. Now we're going to look at operations with terms. So obviously that's why it was important that I went through what a term was earlier. We need to know what it is before we do operations. So of course we're looking at adding, subtracting, multiplying, and dividing terms. So we'll start with adding and subtracting. So you can only add or subtract terms if they are like terms. So like terms have the exact same sequence of pronumerals. For example, 2x and 2 are not like terms. That means you can't add them together or you can't subtract one from the other. They both have the same number in them, 2, but only one of the terms has an x. On the other hand, if I have something like 7ab and minus 3ba, they are like terms. So even though there's an ab in the first and a ba in the second, Both terms have one B and one A. They have the same sequence of pronumerals. We don't really care so much about the coefficients. They have one A and one B, therefore they're like terms. It doesn't matter the order in which you write them, write the letters that is, because the order of multiplication doesn't matter. A times B is the same as B times A. That's why they're like terms. So I could add or subtract those two terms together. If I have something like x and x squared, they're not like. So both of them have an x in them, but this one here actually has two x's because x squared is x times x. So you have to have the same sequence of pronumerals, but they have to have the same powers. If I have something like 10xyz and let's say 15xy, they both have an x, they both have a y, but only this one has a z. So those are, again, not like terms. I cannot add or subtract them. So when you are adding or subtracting like terms, all you do is add or subtract the coefficients. So if I have 6x plus 2x, we have one term, one term. They are like terms, so I can add them together. So I just add the coefficient. 6 plus 2 is 8, and I have an x there as well. So sometimes you'll get expressions that you have to simplify, where you have to collect like terms, but not all the terms are like. So if I have something like 7a minus 3b plus 2a, I just look at those that are like terms. So 7a and 2a are like terms, I can add them together. That gives me 9a. This negative 3b has no like terms, poor old thing, so I just leave it exactly as it is and I don't change it. I might have something like this. 6b minus 7c. So let's say I want to simplify this expression here. So 6b and this term here are like terms. But this term here, its coefficient is not positive 8, it's negative 8. So I need to go 6b minus 8b because of this minus out the front. So again, I just operate on the coefficients. So 6 minus 8 is negative 2b. Minus 7c plus 5c. So minus 7 plus 5 is minus 2. And there I have it. I've simplified it. There are no more like terms to simplify. So one thing I really want you to understand, and please make sure you get this, because if you make this mistake, I will find you, I will come for you. Because a lot of people make this mistake. So note, x plus x gives you 2x. X times x gives you x squared. People always mess this up. So notice when I add 6x and 2x, the answer wasn't 8x squared, it's just 8x. The x squared is only when you're timesing. Please do not get these two things mixed up. So many people do. I'm now going to go through multiplying and dividing terms. So multiplying and dividing terms is much easier because they don't need to be like terms. So you can multiply and divide terms even if they are not like terms. And again, you just operate on the coefficients. So the reason for that is if I have something like 4a times 2, timesing by 2 just means adding the thing twice. I can definitely add 4a and 4a, I just get 8a. You might see it would have been easier just to multiply the numbers together separately and then write the letters, and that's exactly what I do. If I have something like negative 6b times 4c, negative 6 times 4, and then write the letters. And it works the same if I have heaps of things I'm multiplying. So I might have negative 3a times 2b times 6c. So I just go negative 3 times 2 times 6, which is negative 36, and then write the letters. So division usually works the same. So if I have something like 16k divided by 4, I just go 16 divided by 4, and then write the letter. Division gets a bit more complicated when the thing by which you're dividing becomes complicated. So let's say I have something like 18EF divided by 9FG. So it can often be a lot simpler if you write it as a fraction. Because remember, the fraction line means divide. So 18EF over 9FG. Now, if the same letter appears on the top and the bottom of a fraction, you can just cross it out. It's a common factor. So we know 9 goes into itself once, goes into 18 twice. So here, I'm left with, on the top, 2E and 1G, or just G on the bottom. So it can be much simpler to write divisions as fractions. All right, the next thing we're going to go through is expanding and factorizing. So remember, expanding and factorizing involves brackets. You might have an expression like this, and we know that that's the same as this. So if you start with the brackets and then you end up without brackets, that's expanding brackets. And what we use to expand brackets is the distributive law. And then sometimes we want to go the other way. So when you start with an expression with no brackets and you end up with one with brackets, it's called factorizing. And the reason for that is that this is written as something times something. We've written it as the product of factors. So how do you do expanding and factorizing? Well, expanding's pretty easy. If you have something like, say, 2x minus 7, it's called the distributive law because you distribute the thing out of the brackets to everything inside the brackets. If no operation's written, it's times. So 2 times x, 2 times negative 7. Okay, sometimes you will have to expand more than one bracket and then simplify. So I might have something like 3 times 2x plus 1 plus 4 outside of 3x minus 5. Okay, so I'll do each bracket separately. So 3 times 2x, 3 times 1. Please make sure you distribute the thing outside the bracket to everything inside the brackets. 4 times 3x, 4 times negative 5. Okay, now we have some like terms. 6x and 12x, like terms, they can be added together. 3 minus 20, they're like terms. Okay, that's my final answer. So that's how you do expanding. So to factorize, you need to find the highest common factor. And that goes outside the brackets. And then what you do is you divide each term by the highest common factor inside the brackets. So what does that mean? So let's have something like 4x plus 20. So two terms, 4x and 20. The highest common factor, the highest thing that goes into 4 and 20 is just 4. There are no letters in common. So 4x divided by 4, or if you like, what do I times by 4 to get 4x? What do I times by 4 to get positive 20? So note, expanding and factorizing undo each other in the exact same way as multiplication and division. If you take a number, multiply by 5, and divide by 5, you're back where you started. If I take this expression here and factorize it, then expand my answer, I'm back where I started. So let's look at another example. So let's have something like 12ab plus 20b. So here, highest common factor of 12 and 20 is actually 4. There's also a b in both terms, so I need to take that out as well. So what do I times by 4b to get 12ab? I times by 3 to get to 12, and I need an a in there as well. What do I times by 4b to get 20b? The answer is just positive 5. So if I expanded these brackets, I'd get back what I started with. So follow that process all the time. Highest common factor out of the brackets, divide each term by the highest common factor in the brackets. All right, now we're going to look at the index laws. So let's go quickly through the index laws that you need to know. And we first need to know, what do I actually mean by index? Well, hopefully you know by now, if I have something like 5 to the power of 3, it's 5 times itself 3 times. So we call this number being multiplied the base, and we call the little number that tells you how many times to multiply it either the power or exponent or index, and that's where I get the name index laws from. So we're talking about laws involving powers of numbers. So 5 to the power of 3 we say is written in index form because it's something to the power of something, and we say that all the 5's written out is expanded form. So usually the question will ask you to simplify something, giving your answer in index form. So let's look at the laws we went through. So the first law, if we multiply the bases, so here 5 is the base, keep the same base, add the powers together. If we divide the bases, like we're doing here, you keep the same base and subtract the powers. Now, if no power is written, we assume it's 1. 7 to the power of 1 is 7, just like 8 to the power of 1 is 8, etc. So we learned two more index laws that are actually consequences of the first. So if I have something like 8 to the power of 4 squared, so squaring means timesing it by itself. So from the first index law, that's just keep the same base, add the powers. Notice what we've done is we've multiplied together the two powers, and that's the shortcut. When you raise a power to a power, you just keep the same base and multiply the two powers together. That's because of the first index law. We also looked at the zero index. So if I have something like 2 to the power of 5 divide 2 to the power of 5, the first index law means keep the same base, subtract the powers. But 2 to the power of 5 is 32, and I know anything except 0 divided by itself is 1. So 2 to the power of 0 must equal 1. But that logic works for any number. It works whether it's 1 to the power of 0, 2 to the power of 0, 2.32 to the power of 0, any number except 0. So that's our index law. So 0 to the power of 0 is undefined. You'll get an error if you put it on your calculator. But anything else to the power of 0, so x to the power of 0, if x is not 0, that is equal to 1. So x to the power of 0 is 1. 2 to the power of 0 is 1. 4 to the power of 0 is 1. Just make sure you understand what is actually being raised to the power. So if I have something like 7 times 3 to the power of 0, we do, because of BIDMAS, index is second, we do the 3 to the power of 0 first. So this would be 7 times 1. 3 to the power of 0 is 1, which is 7. But if I have 7 times 3 in brackets to the power of 0, I'm raising the whole thing to the power of 0, and that would just be 1. Alright, I hope you found this video informative. Best of luck studying and with your test. This has been the luckiest maths teacher in the world. Have a wonderful day.